So I'm Phil, and I'm an iOS dev from Billu in Sydney. And one of the things I really enjoy is playing with new tools and heaps of new fun stuff. Earlier in the year, I got the opportunity to work with one of our clients on building a watch app to coincide with the launch of the Apple Watch. And essentially what I built was a shopping list app where you could create shopping lists, you could add products to lists, you could see what aisle those products were in, you could check them off as you went, you could have a favorite store, see what time it opened and closed, and you could swipe up the glance and see the store that was closest to you. Since then, I've sort of helped out a few friends that have also been building watch apps, and I've kind of been keeping a really tough eye on the whole watch development space and trying to see where we as developers fit into that. Since I'm a student and I don't have a mortgage, I went ahead and bought myself a Millennials Loop Apple Watch, and I really love it. It's pretty great. But you can believe it or not, I've spent a lot of time trying to understand why it works for me, but for a lot of other people, it doesn't really integrate well with their life. And I've tried to look at the ways that us as developers can sort of improve that experience and sort of make it more engaging. One thing I've noticed about the Apple Watch is that way more than the iPhone, the entire value of the watch is in the value of the apps. So the entire usefulness of this product comes down to how useful and how effective the apps are at engaging users. And right now we're in the really early stages of that, so the apps aren't really great. But if you were watching the keynote at WWDC, watchOS 2 is just about to be launched, and I've played with it a lot, and there's a lot of really drastic changes to the APIs that are coming that are going to let us do really great things to make our apps better. This session, I'm going to break down the process of WatchKit development into a few key aspects that hopefully by the end will give you an idea about how to build apps that don't just do something, but they do it in a way that's really engaging and really intimate for your users. And so I'm going to touch on some of the affordances that we make based on the fact that we're building software that actually runs and people wear on their wrist, and how those affordances can sort of inform the way that we approach our process and the different types of interaction that your user is going to experience your app with, like glances and handoff and notifications, and now even complications. But I've also snuck in a few slides about speed, because I think that we can all really agree that right now watch apps are like ridiculously slow. And of course that's partly because of the fact that we're writing code that runs on an iPhone and communicates with a watch app that's running on a really small, really limited device. But I personally also think it's just a little bit about the fact that we're building for such a limited device for the first time, and it kind of takes a bit of time to get better at that, if anyone knows anything about the iPhone. So let's start off by talking about affordances. Some of the assumptions that we can make based on the fact that people are wearing this device on their wrist. As it turns out, we've all been using smartphones for quite a while, and we use them a lot every single day. I found a study in the UK from last year that asked people how many times they reach for their phone in a given day. And a lot of people said about, at the max, 200 times a day between 7:30 in the morning and 11:30 at night, which is quite a lot. And the survey asked the same people what they were doing when they were reaching for their phone. And most of those users said that they were doing some sort of task that didn't really make sense for them to pick up their Mac or their desktop computer. So what can we actually tell about that? I think it's safe for me to say that in some cases we use our iPhone for something that it doesn't really make sense to use our Mac or to use our iPad. And essentially we use different devices that have different forms, and their form dictates the way that we actually use them, what we use them for. Say I was trying to read a magazine, it would be a really nice experience to read it on my iPad because I could actually pinch at it and grab the corner and turn the page. If I was trying to take a photo at a concert, I probably wouldn't be using my iPad because someone would probably take the iPad and literally hit me over the head with it. But if I was writing an assignment for university, I wouldn't really use my iPhone, even though once I did write an entire assignment back in iOS 6 days in the Notes app, and I got it back and it was like full of typos. But you can see what I'm getting at. People interact with apps on different devices, and it's almost like there's a hierarchy in different levels of interactions that sort of starts to emerge. But anyway, where the hell does the Apple Watch fit into that hierarchy? One thing I've noticed since I've been using my watch is that I tend to use my phone a few hundred times a week, and I'm usually using it for anywhere between a minute and 10 minutes. Mostly I'm on the train, or I'm sitting down eating lunch, I'm at home, or I'm supposed to be paying attention at uni. My watch, I tend to look at it a lot more. I think about 3 or 4 times more than my phone. But when I am looking at my watch, it's only ever in passing for a few seconds at a time, at max 5 seconds. And the more that I think about that in relation to a hierarchy of interactions, these small tasks I'm doing on my watch, I like to call them micro-interactions because they're incredibly small and they never ever warrant any more than seconds of my time, because otherwise my wrists will start to get really tired, or I'll go and I'll find my phone, or I'll sit down at my Mac. And if we take away everything digital about the Apple Watch and just consider it as a watch, what is the actual intention of a watch? What is it supposed to do? Of course, it's something that's made for utility. But I don't think it's just about checking the time. I think it's more about presenting this concept of timely information. It's an object that becomes part of your daily routine. And the idea is it cuts through all this information in the background, so you can just look down at your wrist and see the time and sort of get your bearings. But these days, just being able to see the time isn't really as useful as it was. We're consuming all this new information. In any given day, I'm getting tweets and messages and calls and Snapchats and Periscopes and Slacks and all this other stuff. For me, being able to look down at my wrist every now and then during the day and sort of find my bearings in all that information is way more important than it's ever been. And from all that, we can kind of assume a really simple truth, that people want information, but they want it in a really simple and quick and easy way. If you look at the Apple Watch physically, it's only got 2 screen sizes, 38mm and 42mm, which is not that much. It's pretty tiny. And it also has a really tiny brain compared to the 5K iMacs and the trash can Mac Pros that we're running. But it does have a few sensors. It has a light sensor, an accelerometer, a gyroscope, and a heart rate sensor. But through all those speeds and feeds, what does that actually mean? It means that the watch is really limited, and in order for us to build apps that are actually effective, we have to be presenting as little information as we possibly can. And the information that we do present needs to be contextual. It needs to use things like location and time and date and health to be able to tailor exactly what we show to that user at that time and in that place. And it means that for us to be successful, we need to create interactions that are really subtle and really discreet. We have to distill the essence of our iOS app into a really tiny but still useful and relevant package. Before I look at a few of the interaction patterns that your users are going to approach with your app, I want to consider speed. Because when you think about iPhone and you think speed, you're probably going to think about this really insanely powerful processor that they keep managing to shove into a really thin package every single year. And you're going to think about the guy that wears the scarf and stands on stage demoing his latest 3D game on the new iPhone. But the Apple Watch has no graphics capabilities whatsoever. And you kind of think that this would mean we should be approaching developing for the watch differently. I think we should be less forgiving about what we do and what we ask the processor to do. We should be covering our tracks and trying to find smart ways to accomplish more things by asking for less. And then the Apple Watch launched, and many of our apps hit the store. This is all we saw. I remember the first day of the Apple Watch launch really clearly because none of us had tested our apps except for judging the performance of the app in a simulator that was running on a quad-core dev machine. And then we opened up our Apple Watch with glee and started up our apps, and we just looked at this endlessly spinning ring of death. A few small selections of developers went back to the drawing board, and they actually redesigned their entire watch app just to be faster. But I think a lot of us still haven't really taken that into account and haven't changed our apps that much. So I went to WWDC in June with this in mind, and I knew there was something that could be done. I just needed to find out what it was and where to find it out. So I tailed a few engineers into bars late at night, and I got a few results. Buried in all the documentation for WatchKit OS 1 is a diagram really similar to this, and it outlines the life cycle of a WK interface controller in relation to the actual real-world interactions with a user. And when I first read over this back early last year, I just sort of looked over it really quickly. It didn't take much into account. But actually hidden in this diagram is a really subtle but really important point for speed. The life cycle of an interface controller is only slightly different to what you would expect from a view controller. Structurally, they're the same thing, but in a real world, a view controller is going to get initialized the first time you load it, and then it'll eventually appear on screen, and the user is going to tap around and interact with the subviews for a few minutes, and then eventually the view controller is going to disappear. But an interface controller's did appear and disappear expectation is a bit different. So if we take a scenario, I'm on my iPhone and I'm connected to a blazing fast Wi-Fi or 4G network, and I open up my train timetable app. I tap on the station that I am at, and where the app, we initialize the view controller, and then view did appear gets called, and so we trigger a network request to go and download the latest timetable data. And then it comes back, we're going to update all the subviews with the new timetable. So this might mean that we set all the values and all the labels, and if we've downloaded some images, we're going to set all those images in the image views, and then let's reload the entire collection view so it shows on screen. On a watch, an interface controller is likely to appear, then disappear, then reappear in direct succession a lot more. If I'm a user and I'm walking to the train station, and then I raise my wrist and I flick up my favorite timetable app, and then the view appears, so the app kicks off a network request to download the latest timetables data, but then my arm gets really tired, so I'm going to put my wrist down, or I'm really distracted, I'm going to run to the train, and then I decide, okay, I'm going to raise my wrist again to see the timetable. And what I don't want to do is have to wait for the app to kick off an entirely new network request for the exact same data that I just requested, because I'm just going to sit there and see a spinner twice as long. So I get fed up and I just look at the timetable board because it's really easy. As a user using my Apple Watch, when I interact with apps, whether it's a glance or the app itself or any other view, I don't expect to be waiting. It's a watch, I want the information instantly. So let's step through that life cycle in a bit more detail. We're an interface controller and we get initialized. Yep, we all know this, it's pretty standard. We set up our interface controller, any of the initial values, but we don't really need to be performing any network requests because we're just waking up. For an interface controller to be pushed onto the screen, something had to have asked it to do that. So maybe the user's tapped on a table and we're showing more detail for the object in that row. So the system will call awake with context, and that table row might be able to provide a dictionary that has some contextual data, like a view model for whatever was in the row. At this point, we should be setting initial values for the views on the screen, whether they're labels or images or tables. Awake with context only gets called a second time if the user navigates away from the view and we lose reference to the interface, and then we have to build it up again. So if we need to trigger a background network request, this is the time. The request is only ever going to get created once unless the user leaves the interface and then comes back. And the most important thing to note is that this is where the bulk of all your setup for a view that's on screen happens. Right before the view actually shows on screen, the OS is going to call will activate. And what we should do here, and obviously what we shouldn't be doing, is really, really important. When will activate is called, I shouldn't be triggering another fetch request every time it gets called, because that request can take X amount of time and we have no idea what that's going to be. If the screen's going to turn off while that request is still hasn't succeeded, when we get a response, it's just going to get discarded, and we've probably already requested the same data again when the watch face came back on. And at the same time, I don't want to be using anything like the open parent application reply method, which is actually now deprecated, or the new watch connectivity framework, to be making any requests that have to wake up the iOS app, which could take any amount of time, and then come back. Instead, I should actually just be performing a check to see that at this point, the data I requested in a wake with context is not out of date. And if it is out of date, then yeah, I can schedule a background task assertion for a network request. And a background task assertion is just this method that lets you perform a task when your extension is running in the background. And essentially all you do is give it a block and it gets scheduled to be performed asynchronously on a concurrent queue. And the system will take a background task assertion and then perform your block. When that request comes back, or even if I haven't made a request, I should only be updating the labels and the views on screen whose data has actually changed. If my timetable app went and downloaded all the latest times, gets back, and nothing's changed, except for the fact that the next train might be 5 minutes late, I shouldn't be resetting every single label that's on the screen. And I shouldn't be clearing the labels by setting them to some weird value, like calculating or emptying them, and then setting them to the right value when the response comes back. No matter how tempting it could be, no matter what anyone tells you, don't design your own custom spinner and then blank out the screen and display a spinner while you're making a request. Instead, leave the old, out-of-date data on the screen and only update the values that have changed. By doing this, the user doesn't see your entire interface go black for 3 seconds and then flash back again when your request is done, or your labels jump to calculating, then jump back. It will actually make sense for the user to see all the information on the screen get updated. The system even provides you with a little loading indicator in the top right and a last updated label, and they'll know that your app is getting the latest information. When the user puts their wrist down and the screen eventually goes off, the interface is called on did deactivate. And at this point, your interface is not going to go away forever, because the chances are it's going to come right back, and that might be almost instant. So use this as just an opportunity to clean up your interface. If you're performing animations or you're going to calculate some weird thing that won't be there when you come back, then get rid of it. But the system will actually block any of your attempts to change the value on labels, to clear anything, or to remove anything off screen. This is where thinking about the patterns of interaction of a real user are going to dictate our approach to the WatchKit development process. We have to remember that we're on a watch and the user hasn't stopped what they're doing to sit down and use their phone or to pick up their iPad or their Mac. So we have to cater for that. Users interact with Apple Watch apps on a really small scale, and they don't want to wait for you to build the entire world behind a loading spinner. One of the most important challenges of designing a watch app is getting speed right. If a user has to wait for you, then you've already failed it. Now is the most used interaction that your user is going to see, a glance. If you aren't familiar with watchOS apps, then a glance is essentially just a non-scrollable view that they can access really quickly by swiping up from the watch face. They're optional, and they're not at all a requirement for building a watch app. And that brings me to my first point, which is not all apps need glances. Yeah, your iOS app has the ability to show your user's kill streak in a glance because the data is already there, so why not, right? But no, your user doesn't really care about their kill streak, that they have to keep it and see it every time they go to their glances. You need to understand your user and ask yourself, does this really need to be here? Glances only make sense if what you're showing is relevant and contextual. And that means that the information that you show should be specific to the time and the location and the date of the user. I don't want to swipe up and see Tuesday's weather in California if I'm standing here and it's Monday and I'm in Melbourne. And it sounds like a no-brainer, but there are a lot of apps that are trying to cram their entire data model into a glance. You should be only showing the bare minimum that is possible in a glance. A typical interaction with a glance is nothing more than a few seconds. And harking back to what I was talking about with the whole speed and life cycle, it applies more so than anything else in glances. One of the important tidbits that I picked up from WWDC, and it's not documented in any documentation anywhere, but the system is actually constantly taking screenshots of your app. So, for example, I'm a user and I swipe up from my watch face and my glance appears. You'll see a little loading indicator in the top right and the last updated label at the bottom. And what the user is actually looking at is a screenshot of the glance of what it looked like the last time they looked at it. And underneath that, while that spinner is loading, your glance controller is being initialized and woken up and set up. And once will activate on your glance finishes, Apple's just going to get rid of the screenshot, and whatever your interface looks like, that's what's going to show on screen. So if your interface looks nothing like it was supposed to before, the user's going to see a lot of crazy jumping around and craziness while the UI catches up. So it's really important, if possible, to just to avoid making network requests. You need to be really smart about what you request in terms of data on a device that's this limited. One approach that I took was to have the data ready and waiting for you when you need it. In the watchOS 1 days, I did that by using app groups. I would have the data pushed down to my iOS app in the background, and I would store those changes in the app group. And then whenever my watch needed to access it, it was really easy, just a matter of loading that from the container. And in watchOS 2, they've deprecated open parent application reply, and they've actually recommended that you keep the data of your watch app and your iOS app completely separate. So one way that you would avoid network requests might be to still push changes down to your iOS app in the background. And then when your glance awakes, all the watch needs to do is open up your a watch framework session with your iOS app, and then pull down what it needs and show it on screen. Glances are really like the most important interface that your users are going to interact with your watch app. Glances are all about quick access, so you need to minimize network requests as much as physically possible. Focus on solving one single user's need, like a weather app that shows the current weather. If I need the full forecast for the week, I can tap and go into the app. Or if I'm a train app, I only show the next 3 trains, and if I need more, I tap into the app. And you need to test the hell out of your glance. Make sure that it works consistently. Don't fail network requests because you've failed to cater for the fact that the users put their wrist down while you're requesting something. If your glance works consistently well, your user will start to rely on it and trust it more. And like my train timetable app, it works every morning. So every morning I know that I can trust it, and I'll flick open the glance and see the exact times that I need and I expect. And there's no hassles. Another interaction pattern is handoff. And it was introduced last year with iOS 8 and Yosemite. And it works with watch apps too. Handoff is really great because it comes back to my whole idea of different devices having different types of interaction. And it sort of materializes in a pyramid shape, starting at the watch and trickling down to the Mac and the iPhone. The user gets pulled into the pyramid if they get a notification or if I manually check up on a glance. I might receive an email, but it looks really long, so I'm going to grab my phone and read it there. But then I've read that email and I want to write this really long-winded reply, so I'm going to pick up my Mac and I'm going to send a response. And having that seamless integration across different devices gives you the chance to keep users inside your app, and depending on and cater for the different levels of interaction that users can be having with your app, depending on what they're actually doing. That's why it's really important to be understanding of your users and how they're interacting with your app. Ask yourself what they're doing the most, and when they're doing it, and why they're doing it, and try to look at what that experience is going to be like, and whether it can be improved on a different device in a different form. I really recommend sketching out a diagram like this one, and sort of take a look at the flow from the WatchKit app up to your phone and to your Mac, and ask yourself what screens they're going to be needing to see and what information needs to carry on from one screen to the next. It'll inform your development process. On a technical level, handoff is actually ridiculously easy. All you do is use this method to update user activity, user info, web page URL, and you're constantly pushing user activity to the OS, which takes care of everything else. You might provide a little user info dictionary every time you publish, and it contains some form of information that you expect to be able to unravel on the other side. So if a user opens up your train glance on Wynyard Station, you immediately update the system with a dictionary containing the view model for Wynyard. And then when they swipe up on their iPhone, they're dropped immediately into your app, which awaits and gives you this same user info object that you use to unravel and drop them into a really nice detailed view of Wynyard Station. Another interaction is notifications. Notifications are really important for making your users aware of changes to your app as they're happening. And in OS 2, there are a lot of really nice APIs and changes to notifications that can make your notifications more engaging and useful and less obtrusive than they were. On the Apple Watch, they arrive in a few different shapes and sizes. They make sounds and they trigger haptic feedback, and they show you a short glance interface with less detail, and then a really long glance interface with more detail. And some of them have action buttons that your user can actually use to make decisions on notifications without opening your app. And they all serve this one purpose of getting information out of the way and allowing your user to do things faster and dismiss incoming information faster. For me, one of the shining moments of Apple Watch is being able to use haptic feedback. I can be alerted of different types of notifications without even having to look at the screen of my watch. I know what a text message feels like in comparison to a tweet, so I can ignore a really unimportant tweet at an unimportant time without even having to tap or look at anything. And in OS 2, Apple's going to give us a lot of APIs to customize the type of taps that our notifications can send. If you use WK haptic type, you can send notification, direction up, direction down, success, failure, retry, start, stop, and click, and they're all going to sound slightly differently. At WWDC, I went to a really great session from Jake Behrens called WatchKit Tips and Tricks, and he demos all of these sounds, and you can actually hear what they sound like in comparison. So I recommend that you check that out. And the final interaction that I want to briefly touch on is complications. Complications were introduced at WWDC as part of OS 2, and I spent a lot of time playing with them in the beta, and I think that they really round out my idea of creating intimate interactions with users. I think complications are great, and they make a lot of sense when you think about what complications actually are. And really, they're just another way to distill all this complex information that's weighing your app down into a really tiny modular window that lives on the face of the Apple Watch. And just like a glance, not all watch apps need complications. But for the few watch apps that do, they allow apps to provide the most valuable information that a user wants to see. To a user, a complication is just a collection of information that they care about the most, because every time they look at the time and they look at their wrist, they're going to see their complications. And your apps have that opportunity now to create a really intimate connection that becomes part of a daily routine for a user. I wasn't going to go into the same amount of detail because Chris was supposed to talk after this about creating complications. But essentially, you get modular small complications, which are the small square ones in the corner, and modular large, which are large rectangles in the middle. And then you get circular small, which are the small circles in the corner. But then you also get access to utilitarian small rectangles and utilitarian large rectangles that take up the full width of the watch face. Not all watch apps are actually suited to using complications. They tend to work best for apps that have data that makes sense if it's configured in a timeline, kind of like notifications. And if your app has information that changes over time, the user might want to be aware of that information in a more subtle way than a notification. And we think about complications as a stack or a timeline that you push dates onto and some sort of piece of data related to that date. So you might think about sports scores that change in significant points over time. But remember that you won't really get a chance to bombard your user with constant changes because the system is actually rendering complications in the background, kind of like the screenshots idea, and then caching them and showing them caching them in the background before showing them on screen. But users don't need to see changes in real time. They can scroll the crown and they can actually look at event points from the past. And if you're smart and you choose to, depending on how your watch app data works, events that are happening in the future. Like a calendar app which actually knows what time meetings are on in the future, so a user can time travel forward into the future and see those data points predicted. That was all the interactions that I kind of had time to discuss with you in the session. If you've worked with WatchKit before, you'll know that there are a lot of interesting APIs and changes coming in OS 2. And I want to round off just by saying that as developers, our goal for building apps is to provide a really tangible and meaningful experience for users. And they want to be able to rely on products that when they need them the most. And if we're doing our jobs correctly, then users are going to form a trust with our products. Building apps for Apple Watch is a really great opportunity for you to be doing that. And if you do it really well, you can create really intimate interactions and engagements with your users that they're going to use day in and day out. And essentially, that's exactly where you want your apps to be. So thanks heaps for your time, and come find me and say hi, and I hope you enjoy DevWorld.